Every uranium mine begins with years of geological exploration. Scientists search deep underground for uranium-rich rock formations.
Gamma radiation detectors help identify uranium-bearing zones. Initial readings guide drilling locations. Core drilling confirms the depth and quality of uranium deposits. Each sample reveals valuable geological data. Core samples reveal the concentration of uranium minerals. Geologists analyze every layer in detail.
Laboratory analysis determines whether mining is economically viable. Only high-quality deposits proceed to development.
Engineers design the safest and most efficient mining method. Detailed mine plans are created before excavation. The mining site is prepared for large-scale operations. Infrastructure must be built before extraction begins.
Strong haul roads are essential for transporting ore. Massive mining trucks will soon use these routes.
Specialized equipment is transported to the mine. Each machine is assembled for heavy-duty extraction.
Mining machines are assembled directly on site. These powerful excavators can move thousands of tons daily.
Radiation protection is critical in uranium mining. Every worker carries personal monitoring equipment.
Layers of waste rock must be removed first. This process exposes the uranium-bearing ore beneath.
After overburden removal, uranium ore is exposed. Geologists verify the mineralized zones.
Blast holes are drilled into the uranium ore body. Controlled blasting prepares the rock for extraction. Engineers carefully load explosives into the prepared blast holes. Every charge is positioned for a controlled rock fracture.
Safety teams perform multiple checks before detonation. The blast zone must be completely secured.
Controlled blasting breaks the uranium-bearing rock. The goal is maximum fragmentation with minimum waste. Powerful excavators begin loading the broken uranium ore. Thousands of tons are moved every day.
After blasting, inspectors evaluate the fragmented ore. Radiation and ground stability are carefully checked.
Powerful excavators begin loading the broken uranium ore. Thousands of tons are moved every day. Haul trucks transport uranium ore to the processing plant. Each truck carries enormous loads of mineralized rock.
Large ore fragments must be reduced in size. The crushing process begins immediately.
Massive crushers reduce the ore to manageable sizes. This improves efficiency for downstream processing. Conveyor systems move ore continuously through the plant. Material handling is highly automated. Secondary crushers produce a more uniform particle size. This prepares the ore for grinding. Screening separates fine and coarse material. Oversized rock is returned for additional crushing. Grinding releases uranium minerals from surrounding rock. The ore now enters the milling stage. Inside the mill, steel balls crush the ore repeatedly. The material gradually becomes a fine powder. Water transforms the powdered ore into slurry. This allows chemical extraction to begin. The slurry enters leaching tanks for uranium recovery. Chemical reactions will separate uranium from the surrounding rock.
Chemical leaching dissolves uranium from the crushed ore. The valuable minerals enter the liquid solution. Over several hours, uranium gradually dissolves into solution. The process maximizes recovery from the ore. The uranium-rich slurry is transferred for solid liquid separation. Next, the valuable solution will be isolated. Heavy solid particles settle to the bottom. The uranium-rich solution remains above.
The clarified solution contains dissolved uranium compounds. It is now ready for concentration and purification.
Specialized resin captures uranium from the solution. This greatly increases uranium concentration.
Uranium ions bind to the resin material. Most impurities continue through the system. A stripping solution removes uranium from the resin. The recovered liquid now contains concentrated uranium. The concentrated uranium solution moves to precipitation tanks. Chemical reagents will recover the uranium. Chemical precipitation converts dissolved uranium into solid particles. This material is the basis of yellowcake production.
Filtration removes excess liquid from the uranium solids. The concentrate becomes increasingly dense.
Drying removes remaining moisture from the concentrate. The material gradually becomes a fine powder.
The dried uranium concentrate is known as yellowcake. It is the primary product of uranium mining. Each batch undergoes strict quality testing. Purity and compositions are carefully verified. After testing, the yellowcake is prepared for secure packaging. Special containers prevent contamination during transport. Automated systems fill each drum with precise quantities of yellowcake. Strict controls ensure accurate weight and containment.
Each container is securely sealed for transport. Containment prevents loss of material during handling.
Every drum receives tracking and safety information. Documentation follow the product throughout its journey. Packaged yellowcake is stored in secure facilities. Every container remains under strict monitoring. Quality inspectors verify every packaged container. Safety standards must be met before shipment. Logistics teams coordinate transportation schedules. Every shipment follows strict regulatory requirements.
Manifest approved, staging for transport.
Specialized vehicles transport uranium concentrate. Cargo security is checked repeatedly.
Final transport inspections ensure compliance. Every shipment must satisfy safety regulations.
The finished uranium concentrate begins its journey. It now travels to specialized nuclear processing facilities. Mining leaves behind large volumes of processed waste. Tailings management is a critical responsibility. Water quality is continuously monitored around the mine. Environmental protection remains a long-term priority. Scientists test samples for any environmental impacts. Continuous monitoring supports regulatory compliance.
Air quality stations track dust and radiation levels. Data is collected around the clock.
Mine closure planning begins long before mining ends. Future land restoration is carefully designed.
Air quality stations track dust and radiation levels. Data is collected around the clock.
The mining process is complete, but uranium's journey continues. Yellowcake must undergo several more industrial transformations.
Each shipment undergoes verification upon arrival. Safety and accountability remain essential.
Incoming material is tested before further processing. Scientists confirm purity and composition. Quality control ensures consistency between shipments. Approved material moves to conversion operations.
This is the conversion preparation stage, where uranium yellowcake is transferred into the processing vessels.
Intermediate storage balances production and quality control. Continuous monitoring protects product integrity.
Processed uranium becomes the starting point for fuel manufacturing. Precision is critical at every step.
Here, uranium is transformed into fuel for nuclear reactors. The process requires advanced manufacturing technology. Fuel fabrication combines precision engineering and strict safety. Every component must meet exact specifications. The processed material is prepared for fuel production. Particle consistency is carefully controlled. Uniform pellets are produced under tightly controlled conditions. Dimensional accuracy is essential.
Automated inspection detects even minor defects. Only approved pellets continue forward. The finished pellets move toward fuel assembly production. These components will eventually help generate electricity.
Precision manufactured tubes form the structure of nuclear fuel rods. Every component is inspected before assembly. Fuel pellets are loaded into specialized tubes. The pellets are arranged in precise sequences. Each fuel rod is securely sealed. Advanced welding ensures structural integrity. Every fuel rod undergoes extensive inspection. Strict quality standards are maintained. Individual fuel rods are combined into complete assemblies. These assemblies are designed for reactor operation.
Completed assemblies are carefully inspected. Precision ensures reliable reactor performance.
Protective transport systems safeguard the finished fuel. Documentation accompanies every shipment.
The uranium fuel has reached its destination. Here, it will help generate electricity.
Incoming fuel is carefully documented and inspected. Verification procedures are mandatory.
Fuel assemblies remain in secure storage until needed. Environmental conditions are continuously monitored.
Incoming fuel is carefully documented and inspected. Verification procedures are mandatory.
Fuel assemblies remain in secure storage until needed. Environmental conditions are continuously monitored.
Nuclear reactors convert uranium fuel into usable energy. Advanced engineering controls the process. Fuel assemblies are carefully positioned inside the reactor. Precision handling ensures safe operation.
Uranium fuel produces heat that generates steam. That steam drives turbines to create electricity.
Uranium mining is a global industry spanning multiple continents. Different regions use specialized extraction methods.
Many uranium deposits are extracted using open-pit mining. This method is effective for shallow ore bodies.
Deep deposits often require underground mining. Specialized infrastructure supports safe extraction.
After blasting, ore is transported to the surface. Efficient material handling is essential underground.
Some uranium is recovered without traditional mining. This method is called in situ recovery.
Recovery solutions circulate through underground formations. The dissolved uranium is brought back to the surface. The uranium-rich solution returns to processing facilities. Recovery occurs without large-scale excavation. Groundwater monitoring is a critical part of in situ recovery. Environmental protection measures operate continuously.
Worker safety remains a top priority. Continuous monitoring helps maintain safe conditions.
Modern uranium facilities rely heavily on automation. Operators supervise complex industrial processes.
Advanced monitoring systems improve efficiency and safety. Real-time information supports rapid decision-making.
Automation is transforming the future of uranium mining. New technologies aim to improve safety and productivity.
Artificial intelligence helps optimize mining operations. Data-driven systems support more efficient resource management. Mine closure planning begins years before production ends. Every stage is designed to ensure long-term stability. The decommissioning stage is critical. These massive haul trucks must be meticulously cleaned before components can be safely removed for inspection.
Temporary mining infrastructure is removed from the site. The goal is to restore the landscape as much as possible. Water management systems help protect surrounding ecosystems. Monitoring continues long after mining activities end.
Native vegetation plays a vital role in land restoration. Over time, ecosystems gradually recover.
Scientists continue monitoring reclaimed sites. Long-term studies verify restoration success.
Successful restoration encourages wildlife to return. The landscape begins a new chapter. Uranium mining has evolved dramatically over the decades. Technology and safety standards continue to improve.
Modern innovations are reshaping uranium mining. Automation improves both efficiency and safety. From hidden ore deposits deep underground to electricity generation, the uranium journey spans science, engineering, and environmental responsibility.
The uranium cycle can be simplified into key transformation stages. Each step converts raw ore into usable energy.
Safety systems are essential throughout uranium mining. Continuous monitoring protects workers at every stage.
Radiation monitoring ensures safe working conditions. Data is continuously recorded and analyzed.
Emergency preparedness is a critical part of uranium mining. Regular drills ensure rapid response capability. Environmental barriers protect surrounding ecosystems. Modern mines prioritize long-term sustainability.
Water treatment systems remove contaminants from process water. This ensures safe discharge or reuse. All discharged water must meet strict environmental standards. Continuous sampling ensures compliance.
Air quality monitoring reduces environmental risks. Data helps control dust and emissions. Uranium mining supports local economies and infrastructure. It contributes to energy security worldwide. Technology has transformed uranium mining over time. Automation improves safety and efficiency. The world is shifting toward diversified energy systems. Nuclear energy plays a supporting role in global supply.
Safety and responsibility define uranium mining operations. Strict protocols protect people and the environment. Safety and responsibility define uranium mining operations. Strict protocols protect people and the environment.
From deep beneath the earth to the power that lights our cities, the uranium journey continues to shape our modern world. A journey that begins deep underground and transforms raw rock into powerful energy. Uranium begins its journey millions of years underground, formed through ancient geological processes.
The first step is always discovery. Advanced tools locate hidden uranium deposits.
Look at that spike! We found it!
Once identified, drilling begins the extraction process. Precision ensures efficient resource recovery.
The mining cycle continues with controlled extraction. Efficiency and safety guide every movement. From crushing to grinding, ore is refined step by step. Each stage prepares uranium for extraction. Secure transport ensures safe movement of nuclear materials. Every journey is tightly controlled. Modern mining includes full environmental responsibility. Restoration ensures long-term ecological balance. Technology drives modern uranium mining forward. Automation improves precision and safety.
Uranium powers the world through nuclear energy. From ore to electricity, the cycle is complete. Behind every discovery are people dedicated to progress. Science and effort power the modern world.
From deep earth to global power, a journey shaped by science, responsibility, and innovation. Uranium mining is a complex balance of power, safety, and responsibility. Thank you for watching.